Case 2 is when the degree of the numerator is less than the degree of the denominator. When this happens, then the denominator is getting larger faster than the numerator. What we see then is that if the denominator is getting larger a lot faster, so the denominator is getting much larger than our numerator, when we divide by such a large number, it makes our whole fraction go to 0. So the graph, the outputs will go to 0 on either side. This means that the limit as x goes to positive or negative infinity of our function will be 0. Automatically we'll know that the limit as x goes to negative infinity will be 0, and the limit as x goes to positive infinity will be 0. And we'll have a horizontal asymptote at y equals 0. Here's an example. We have x minus 3 over x to the 4th minus 3x cubed minus x squared plus 19. Here the degree of the numerator is 1, and the degree of the denominator is 4. Since the denominator is greater, then we'll have a horizontal asymptote at y equals 0. Let's check this with a graph. We really need to zoom in to see this graph, but what we see is that still our middle is a lot of weird stuff, but what happens is as we go off to the far left side or the far right side, our outputs go to 0. This gives us a horizontal asymptote at y equals 0. Do make a special note, we can cross the horizontal asymptote in this middle area where everything's really weird. We just can't cross it when we are looking at the ends. So when we get out of the middle area and we're looking at everything on the far left or far right side, we won't cross the horizontal asymptote. But in the middle, we can. And that matches up with what we saw about limits. The limit as x goes to negative infinity of our function, the output 0. As x goes to positive infinity, the output also goes to 0. This will occur whenever your denominator has a higher degree than your numerator. If that makes sense, you can go on to case number 3. If not, make sure that you do understand both cases 1 and 2 before going on to case number 3.